fractions, adding fractions, adding fractions.
All right, it's Mr. Barbera. Let's add some fractions. So, when we're adding fractions, first we're going to change to a common denominator. Once we have all our fractions with a common denominator, we're going to add our numerators, but we're going to keep the denominator. So I'm going to start my first problem. We're going to talk about when we have a common denominator already. So if I have something like 1/2 plus 3/2, I already have a common denominator, so that first step's done. I'm going to add the numerators. So this is going to be like 1 plus 3. And the denominator stays a 2. Because what we're saying is if I have 1/2 and I add 3 more halves, I'm going to have 4 halves. Right? The size of the piece never changed. It's just how many of that piece I have. In this case, we can actually simplify this here. So 4 divided by 2 is actually 2. So the answer is 2. So kind of a funky looking 2 there. Let's take a look at another one. If we had a common denominator already, so like 3/5 plus 9/5. Again, the denominator is already fifths, so my answer is going to be fifths. My numerator, I'm going to add 3 and 9, and that's going to give me 12/5. In this case, we might as well change it to a mixed number here. So 5 goes into 12 2 whole times. It's going to be 2. And then with 2 left over, so those 2 are 2/5 that are left over. We had 12/5. 10 of them made the 2 wholes, and then the other 2 made 2/5. All right. What if we don't have a common denominator? So let's see a couple here without a common denominator. If I have 2/5 and I'm adding that to 3/10, we need to find a common denominator. I'm looking for a number that these two denominators go into. So does 10 go into 5? No, but 5 goes into 10, so that's a common denominator. So what I'm going to do is I'm going to multiply 2/5 by a giant 1 that is going to change the denominator to 10. So I know that 5 times 2 will give me 10. So I have to multiply the numerator by 2 as well. That's a giant 1 over here. We call it a giant 1 because it's equal to 1. And we can multiply that because when we multiply a number by 1, we don't actually change the value. So we're not actually changing the value of 2/5. We're just changing the way it looks from fifths to tenths. So 2 times 2 would be 4/10, and then plus 3/10. And now we have a common denominator, so just like before, you're going to add your numerators and keep your denominator, and that's going to give me 7/10. Let's take a look at another one like that. 2 fractions with unlike denominators. Let's say 2, I don't know why I'm doing 2 every time. 2/7 plus 1. Ooh, let's do something that's not common. Let's say 1/5. So, in this case, 5 doesn't go into 7, 7 doesn't go into 5. But we're going to look for a number they both go into. Sometimes what you have to do, if you have a multiplication table, that's a great place to look. You can also just list out all of the multiples of these numbers. So 5 is going to be 5, 10, 15, 20, 25, 30, 35, 40, 45, and on. 7 is going to be 7, 14, 21, 28, 35, 42, and on. You might have noticed that I said 35 in both of those. That's our common denominator here. So I want to make both of these into fractions with a denominator of 35. And I'll go ahead and write that there just so we know where we're going. Again, I have to use giant 1s because I'm not trying to change the value of the fraction, just the way it looks. So 2/7, we're going to multiply by 5/5 because that'll make my denominator 35. And 2 times 5 is 10. So what I just showed right there is that 2/7 is the same as 10/35. 1/5, if I want to make that into 35, I'm going to multiply by 7 on the top and bottom. My giant 1 is 7/7. And we can have 2 different giant 1s because the giant 1s we're just multiplying by 1. We're not changing anything here. 7 times 1 is 7. And now, of course, we can add. So 17/35. I should probably be boxing my answers here. I'm a little lazy with that. Okay. So what if we have more than 2 fractions? So I'll show a couple examples with 3 fractions just to remind you. A, B, C, D, we're on E now. If I have 1/2 plus 3/4 plus 2/5. Well, what do I need to do? I need to find a common denominator for all three of these. So I actually want to show you two different ways that I would solve this problem. One way is to look for a common denominator for all three. So I'm looking for a common denominator for 2, 4, and 5. One way I might do this is I might look for 2 and 5, and I know the common denominators for 2 and 5 are going to happen on the tens. So 5, 10, 15, 20, 25, 30, all of those. And which one of those is 4 going to go into? Well, the 4 goes into 40, you might be thinking, but it also goes into 20. So we can actually make all these go into 20. And that's what I'm going to do. So I'm going to multiply 1/2 by 10 over 10 to make that 10 over 20. 3/4, we're going to multiply by 5 over 5. Again, to make the denominator 20. Sorry about that. So that would be 15 over 20. And then 2/5, we're going to multiply by 4 over 4. And that's going to give me 8 over 20. And again, we can just add them all the way across. So that would be 25 plus 8 is 32 over 20. And you can go ahead and simplify that. We can divide both of those by 2, which would be... Actually, we can divide both of those by 4. Sorry. So 4 goes into 38 8 times. And 4 goes into 25 times. So 8/5. This is also 1 3/5. Now, I wanted to show you one other way you could do this if you were stuck. If you really couldn't find a common denominator for all of them, sometimes what you might want to do, just so you're not sitting there stuck, is go ahead and just add 2 of them. So, for example, 1/2 and 3/4, my common denominator would be 4. So I'd multiply 1/2 by 2 over 2. And that would actually give me 2/4. I'm going to work down on this one here. So 2/4 plus 3/4 plus 2/5. And I can go ahead and add those two. So 2/4 plus 3/4 is going to give me 5/4 plus 2/5. And now find a common denominator for these two, because maybe it'll be easier for you to think in pairs as you work down. In this case, now we can see the common denominator is 20. So I'm going to continue much like we did before. I would multiply this by 5 over 5. This by 4 over 4. And that would actually give me 25 over 20 plus 8 over 20. Notice that if we added these two together, we would have gotten 25 over 20. And that does come out to 32 over 20 again, which is still going to be 1 3/5. All right, there you go.